I am Mr. True. In this video, we're going to do 3 examples to show you how the quadratic formula, which is x equals the opposite of b, plus or minus the square root of b squared minus 4ac over 2a, will allow you to find the x-intercepts, roots, zeros, solutions, pick your name, whatever your teacher's using, to find the place where these parabolas cross the x-axis. And we are doing parabolas. We are finding solutions to quadratic equations, which means that we're looking at an equation that has a highest degree of 2. And when you have a graph or an equation with an exponent of 2 or a degree of positive 2, that is going to form a parabola. So we've got this equation that's going to help us, this formula. Inside the square root symbol, we have something called the discriminant. It's the b squared minus 4ac part of this formula. And if the discriminant is greater than 0, then you're going to have 2 solutions. That means that the parabola that is formed by this quadratic equation, if you were to replace the 0 with a y and graph it, that parabola would cross the x-axis at 2 unique points. Now, these can be integers, whole numbers, they can be rational numbers, or they could be values that maybe you probably couldn't find with factoring, which could be irrational numbers like square root of 7. And that kind of makes sense because where is the discriminant? The discriminant is inside a square root symbol, right? And when you square a positive number like 16 and get 4, well, that's not the only answer. The square root of 16 is 4 and negative 4. And there is a plus or minus in our formula, and thus we have 2 answers. If the discriminant, if the value inside the square root symbol is negative, unless you're learning about imaginary solutions or values, there is no solution, or there's certainly no real solution. That means that the parabola does not cross or touch the x-axis. And then finally, if the discriminant is equal to 0, the value inside the square root symbol, the square root of 0 is 0. Now you could say, positive and negative 0, but when you add by 0, nothing happens anyway. So what difference does it make if you're adding it or subtracting it? And you only get, therefore, 1 solution. And we are solving quadratics, and they may or may not be factorable. They may or may not have only one term with the variable x in it. So when you have a trinomial, when you have an equation, I guess it could be a binomial as well, but when you have an equation where your variable, and we are talking about the independent variable here of x. I know there's a, b, c, but that's just a general standard form equation. When you have a second degree and a first degree term, it's impossible to get x by itself. So we are not going to be, these are not linear equations. We're not going to get, we're not going to add by number, divide by number, and then boom, have x equal 10. This is a quadratic. We have a first and a single degree term, so we are not going to get x alone. That's not possible to solve these equations this way. We're going to get these equations set equal to 0, and then apply the quadratic formula. So here we have an example. We're going to do 3 of them, by the way. 3x squared plus 10 equals 4x. Now, I already have this x term sort of alone, so if I were to attempt to solve for that x by dividing 4 from everything, I would have this x alone, but I would still have an x squared on the left-hand side. And then what am I going to do? Try and get rid of the 3/4 by multiplying 4/3 to the whole thing? If you have a second degree term and a first degree term, trying to get x by itself doesn't work. Get it equal to 0. So we're going to move the 4x over with subtraction. It is a positive 4x right now. So we're going to move it over with subtraction. We're going to subtract 4x from both sides of the equation and get 3x squared minus 4x plus 10 equals 0. And I'm going to put the 4x in the middle. I want my exponents to count down in degrees. I have a degree of 2, I have a degree of 1, and then this is just a constant of 10, which has, we say that has a degree of 0. We're going to identify and look at this general form or standard form of a quadratic and identify our values of a, b, and c, a being the coefficient of the x squared term or the leading coefficient, b being the coefficient of the single degree term, and c being the constant. So, We have an a value of 3. We have a b value of -4, and we have a c value of 10. Now, if you're just learning quadratics and you're early in algebra, you might, hopefully not, but might still be having some trouble with your negative signs. So I like to just reiterate to students that, because in this example, b is -4, so we're applying a negative, putting a negative into the equation, or the quadratic formula from our problem. Plus, there's already a minus sign there in the equation. So, before you even worry about what the numbers are, I suggest doing this. Write the quadratic formula out, and don't even consider what these numbers are. Just leave a set of parentheses everywhere there's a variable, and then do your substitution. So, x equals negative b, or the opposite of b, plus or minus the square root of b squared minus 4ac all over 2a. And see, this way, I will see that there's a negative from the equation, and there's a negative from the 4 that I'm plugging in with the equation. And if I've already written this negative, and then I see that the 4 is negative, I tend to get fewer sign errors from my students if I highlight it. Just, write the equation out with the open parentheses and then plug in the numbers. Don't worry about the signs or what the numbers are at first. b is -4. b squared minus 4a, which is 3, c, which is 10, all over 2a. Okay, now it's just a matter of being very, very careful with the order of operations and our arithmetic. Two negatives multiply together make a positive. That is -1 times -4. So 4 plus or minus the square root, -4 squared. Really hope you don't need your calculator to do -4 squared. 4 times 4 is 16. But if you are just, one of those kids, tippity-tap on the calculator constantly, you're really doing yourself a disservice. But if you're not careful with your parentheses, if you're not careful with what's called your syntax, how you type it into your calculator, you might think this is -16. Because you need to put those parentheses into your calculator, or just do it in your head. -4 times -4 is positive 16. And we have -4 times 3 is -12, and -12 times 10 is -120. 2 times 3 is 6. We have 4 plus or minus the square root. Now, this is positive, this is negative. So I'm going to subtract these numbers. 120 minus 10 is 110. 110 minus 6 is 104. Now I said 104, but it is negative. My absolute value, my largest number, kind of, if you ignore the negative number, or the negative sign, 120 is bigger than 16. I just said 120, right? Not -120. 120 is bigger than 16, and 120 now, looking at the sign, is negative. So -120 plus 16, you keep the sign of the larger number, if you will, saying larger in the fact that you're ignoring the negative sign temporarily, and you get -104. You cannot square root -104, so there is no real solution. That's my abbreviation for solution. So this first example is done because I can't find a real solution. That means that my parabola is not crossing the x-axis anywhere. So I'm going to erase all this because my next two examples are going to take a little bit more work, and then we'll be done. Bam! Here's our second example. 2x squared minus 8x equals 1. If we were going to solve this using completing the square, we would have to divide all of our terms by 2 to get our leading coefficient equal to 1. But we're not doing completing the square, we're using the quadratic formula, which means that we need to get this set equal to 0, find a, b, and c, and work through the quadratic formula that we just copied down. So we're going to move this positive 1 over to from the right-hand side of the equation to the left. Anytime you move a term from one side of an equation to the other, you must do the opposite math operation that's holding it on that side. This is a positive 1. We're going to subtract 1 from both sides of the equation and get 2x squared minus 8x minus 1 equals 0. Identify a, b, and c. Do not do this until your degrees, again, your exponents are going down. by 1. So if there was no x term and it was just 2x squared minus 1 equals 0, well, with only one term, when only one term has an x in it, you could just solve for x. But we would add the middle term in there as 0. You want the exponents to count down by 1. Anywho, a is equal to 2. B is equal to negative 8. Stressing those signs again, that's why I'm having all these negatives in here. And C is equal to negative 1. And, again, just to minimize sign errors, I'm going to write the quadratic formula, but only with a bunch of open parentheses. So the formula, x equals, the quadratic formula, the magic formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, go to my ABC values, plug them in. Negative b is negative 8. B squared, or opposite of b, that happened to me to say negative b. B squared minus 4a, which is 2c, which is negative 1, over 2a, which is again a 2. And you might find it beneficial to just sort of do all the arithmetic from the inside that's inside your square root symbol, sort of like off to the side. It'll save you some writing. Let's see what I do here. We've got negative and negative is positive 8, plus or minus. I'm going to go ahead and write it every step, but I remember when I was learning this, I would just take the little bit outside and just kind of do some scratch work and plug it back in so I don't have to write as much. Negative 8 squared, negative 8 times negative 8, positive 64. Don't let your calculator tell you it's negative because you forgot the parentheses. 64, better yet, do it in your head. Negative 4 times negative 1 is positive 4, times 2 is 8. All over 4. And x equals that. 64 and 8 is 72. Again, over 4. And I'm going to do my work in exact format. That means no decimals. To just, reiterate give you examples of simplifying those square roots instead of just typing this into your calculator and getting a decimal. The decimal is okay for when you're graphing, but really now you're probably in Algebra 2, but even if you're in Algebra 1, you need to work on your simplifying skills for your square roots. So we're going to look at 72, and I want to simplify the square root of 72. Well, that means when I say simplify, again, no decimals, I'm looking for perfect squares that go into 72, like 4, 9, 16, 25. 6 times 6 is 36. So 36 times 2 is 72. So this is going to become 8 plus or minus, I'll split that up in a second, 72, which is going to be 36 square root of 36 times square root of 2 over 4. And now I'm going to split this up into, I'll split it in 2 parts. Your teacher may not care if you do or not. The square root of 36 is equal to 6. So we have, I'm going to keep it together, never mind. 8 plus or minus 6 square root of 2 over 4. I just started to realize I had some cancellation left to do, so I didn't want to write any more than I needed to. 4 is even. 8 is even. 6 is even. These 3 terms all have factors of 2 in them. Now, a lot of students, this has all numbers, so maybe not as many people would make this mistake, but a lot of students might go, oh, well, 8 divided by 4 is equal to 2, and they write 2 plus or minus 6 square root of 2. No. You cannot cancel out terms. You can only cancel out factors. So I need to take a factor out of these top 2 terms that may help me cancel with the denominator. These 2 are even. That means I'm going to divide out or factor out of 2. So 2 parentheses. 8 divided by 2 is 4. 6 divided by 2 is 3. Over my denominator of 4. Now 4, if I want to get really fancy, is 2 times 2. And now these factors, you see how these are multiplied to something else? They're not added to something else. They're not terms. They're factors. Those will cancel out. My final answer is 4 plus 3 square root of 2 over 2. And if you want to write these separately, 4 minus 3 squared to 2 over 2. And that's my second example. One more, be right back. Bam! Last example! Okay, use red chalk, but it doesn't show up in the camera very well, so I'm going to use orange for don't do this! We got 4x squared equals a negative 6x. I want to solve this quadratic formula. Or, excuse me, quadratic equation. Well, both terms have an x. I could just divide both sides by x. Cross that out. X squared divided by x. Some of those cancel out. And you end up with 4x equals negative 6. I'm just going to divide both sides by 4. And get x is equal to negative 3 halves. Well, guess what? I don't know if your teacher would give you any points. I might give you a couple, but I had maybe a 5 or 6 point question, but that is wrong, wrong, wrong. Don't ever divide away a variable. You are throwing away some of your answers. How should this have been solved? Well, we got 4x squared equals negative 6x again. Again, single degree term, or excuse second degree term, first degree term. Do not try and get x by itself. Get that equation set equal to 0. We're going to take this negative 6x and move it to the left. With addition, because it's negative, we want to do the opposite math operation. This is a negative 6x. We're going to add 6x from the right to the left-hand side. We're going to remember that these are not like terms. This has an exponent of 2. This has an exponent of 1. So we're not going to do 4 plus 6 is 10. Now at this point, you have 2 ways to solve this. Honestly, the quickest way is by factoring. These 2 terms both have a common factor. These both have an x, and for that matter, they both have a value of 2 in them as well. But I'm going to leave the 4 and 6 alone and recognize that these 2 terms both have an x in them. So I'm going to factor that x out. I'm going to divide, well, let me not assume how strong your factoring skills are. We're going to take this x out with factoring. That means I'm going to pull it out of those 2 terms. I'm going to undistribute it. I'm going to divide it out. And get x is equal to, x times 4x plus 6 equals 0. Now, here is one factor, one item, being multiplied by another item. The parentheses lock all this together. I know there's 2 terms in the parentheses, but the parentheses are holding it together. So this is one thing being multiplied by another thing, and it equals 0. The only way you can multiply 2 terms together, or 2 factors together, and get a product of 0 is if one of them are 0. So when you're solving equations by factoring, you factor it, and then you set each one equal to 0. And we have one answer already. X is equal to 0. Move the 6 over with subtraction. Divide by 4. And get x is equal to negative 3 halves, which we did get, but we lost the other answer. Now, the other answer that this process throws away is not always going to automatically be a 0. You know, maybe it is, I don't know. Do a bunch of examples and see if I'm right or wrong. I don't know, but don't throw away answers. Don't divide away variables. So we have the negative 3 halves and the 0, which dividing both sides by x got rid of, and thus we only had half of the possible answers. And I really probably, as someone comfortable with algebra, would have done this just like I showed you. But since we're learning how to do the quadratic formula, when you set up to use the quadratic formula, your exponents have to count down by 1. Your degrees of each of the terms must be decreased by 1 as you go from high to low. Exponent degree of 2, exponent degree of 1. Constants have a degree of 0. That means that A is going to be equal to 4. B 6, and then C 0. Plug those numbers into the quadratic formula. Negative, or the opposite of B, plus or minus the square root of B squared minus 4AC all over 2A. We have negative 6 plus or minus the square root. The 4 and 4 make 16, but then you multiply it by 0. So really this is just the square root of 6 squared over 8. The square root and the square are going to cancel out, or you would add 6 squared is 36. Square root of 36 is 6. And we have negative 6 plus 6 over 8. Whoops, excuse me. And negative 6 minus 6 over 8. Negative 6 and positive 6 make 0, and 0 over 8 is 0. And this is negative 12 over 8. And I'm pretty sure, since these are both divisible by 4, that that's going to reduce to the answers that we just got a second ago of negative 3/2. I'm Mr. True. That's the quadratic formula. Bam! Go do your homework.